boom, boom, boom. There we go. Okay. Now, on this, it says a graphing calculator is required because it really, really helps you out. Okay. A, on the first one, that particle is moving along the x-axis at a positive time, and the acceleration is 12t minus 18 at t equals 1. The velocity is 0, and its position is 9. Okay? What's the velocity of the particle? Well, if this is the acceleration right here, part A, then we integrate that. So we get 6t squared minus 18t plus c, correct? Okay, so that would be the velocity of the particle. And then we know the velocity at time 1 equals 0. So if we put in a 1 for each of these, so 0 equals 6 times 1 minus 18 times 1 plus c, then 0 equals negative 12 plus c, so c must equal 12. So the velocity function at any time would be 6t squared minus 18t plus 12. Okay, part A. Part B, at what time does a particle change direction? We talked about this yesterday. When a particle changes directions, its velocity becomes 0. So you set this equals 0. 6t squared minus 18t plus 12 equals 0. I'd factor out a 6 to get t squared minus 3t plus 2 equals 0. And t minus 2, t minus 1 equals 0. So the time is equal to 1 and 2 seconds. No, not n0, because 6 equals 0. There's not a variable out there. Okay, so the times would be 1 second and 2 seconds. Okay, part C. Write an expression for the position. Well, the position is the integral of velocity. So if you integrate velocity, integrate 6t squared minus 18t plus 12 dt, then you get t cubed, so that would be 2t cubed minus 9t plus 12 9t squared plus 12t plus c. And then you know the position at x equals 1 equals 9. X of 1 equals 9. So the position at 1 second is 9. So you set 9 equal to 2 times 1 cubed minus 9 times 1 plus 12 times 1 plus c. So 9 equals 2 minus 9 plus 12 plus c. 9 equals negative 7 plus that. That's 5 plus c. So c equals 4, right? So the position is 2t cubed minus 9t squared plus 12t plus 4. So x sub t is a position. I think they wanted us to use there. And find the total distance traveled. Well, the total distance traveled from 3/2 to 6 is the integral from 3/2 to 6 of the absolute value of 2t cubed minus 9t squared plus 12t plus 4. And this is where you use your calculator and let it give you 176.5. If you got 175.5, you didn't use absolute values. Oh, because yep. It's got to be the velocity. Velocity, 6t squared minus 18t plus 12. The integral of velocity is the total distance traveled. Okay. Okay. So if you would have gotten all that, you would have gotten 9 points on this section. Okay, if you would have known that you do the absolute value but done what I did accidentally and put in the position, you would have still gotten a point for knowing that it's the absolute value, but you get one of the 3 points for that part. Okay, the second part. Grain is being loaded into a silo. So grain is going into a silo. Let's just put it like that. Grain is going into a silo at the rate of G sub T equals 400 e to the negative T squared over 4 power feet cubed per hour. Grain is coming out of the silo. At that time, there's 100 cubic feet at time equals 0 in the silo. Grain is being removed at the rates in the chart. So, estimate the total amount of grain removed at T equals 8 hours using left-hand Riemann sums. Okay? So, a left-hand Riemann sum, you take the time elapsed times the left number. So, the first one of the Riemann sum would be 2 hours times 60 is on the left, plus the next one is 3 hours times 90 is on the left, plus 2 hours and 110 is on the left, plus 1 hour and 120 is on the left. And if you add all those up, those add up to 730. Okay? That's worth like 2 or 3 points. And this is where they get you. If you put on a label, that's worth a point. Make sure if they have labels involved that you put on labels, because if this is a 3-point problem, there's 1 point for the label, 1 point for knowing what you're doing, and 1 point for the right answer. Okay? All right, estimate the amount of the grain in the silo at the end of 8 hours. Well, at the end of 8 hours, well, you know there's 100 at time 0. Plus, the amount of grain going in from 0 to 8 hours is 400 e to the negative T squared over 4 minus the 730 going out from part A. Okay, so this is 100 plus 708.982 minus 730 is 78.982 feet cubed. You have to show to a certain extent of what's going on. If you just give the answer with none of this work, you'll still get. Did you have anything about 100 or 730 in there? Yeah, so then that's fine. That's enough. You do not need this. But you should have something with this and this involved with the integral, or else if you only have the integral, then this and this and this in there. Okay? So if you just show the integral first and then put these 3 down, that's your work. And that would be enough. Okay? Part C, estimate the change in the rate at 5 hours. Okay? Estimate the change in the rate at 5 hours. Now, right at time 5, your rate is 110. But you want the change in your rate. So you go below and above and average them. Okay, to find the change in rate. So the rate from 2 to 5 is 110 over 110 minus 90 over 5 minus 2, which is 20 over 3 feet cubed per hour that the rate is. And then from 5 to 7, is 120 minus 110 over 7 minus 5, which is 10 over 2, which is 5 feet cubed per hour. And then we're going to take these two answers and average them. So 20 thirds plus 5 divided by 2, which is 5.83 repeating feet cubed per hour. Now, if you wanted to put it in a fraction form, that would be great. So that would be 15 thirds plus 20 thirds is 35 thirds divided by 2 would be 35.6 feet cubed per hour. Okay, so if you knew how to do all that, there's 18 points. Okay, this I thought was fairly straightforward. Some of the stuff we'll get into, you'll see it and go, what? Really? So this I thought was fairly straightforward. So we're good there. Okay, now let's get out that multiple choice that we did. Uh-oh, that's not right. Well, it might be. Nope. What was our first problem number on this?
31.
31. Yep. All right. I got it. 31. Did it talk about 1 plus cosine squared over cosine squared? No. So I've got the wrong stuff here. So 31 talked about the integral from 0 to 4 of sine x, or the integral of sine x. And cosine x, there we go. Yeah. All right. So here we go. Okay, I don't know where we just went there. Let's go back to AP review. All right. Then, okay, so 31. Let's look at that. So, you have the integral of 0 to pi over 4 of sine x dx plus the integral from pi over 4, negative pi over 4 to 0 of cosine of x dx. And we are wondering what that equals. Okay? Can't you, and this was a calculator one, right? Oh, you guys could just punch that in. And you got answer C, right? Which was 1. Okay? So, yeah. So, I'm not even going to explain that one because this is in the calculator section. So we should be good there. Okay, 32. Oh, I need to see what you're seeing because I'm not seeing what you're seeing. Okay, 32. Which is the right integral for that? And wow. All right, 31. calculator C1. 32. The particle is moving along the y-axis. Its position y sub t equals t cubed minus 4t plus 7, which the following expressions gives the total distance particle traveled in 4 seconds. Okay, so the total distance it traveled in 4 seconds is basically the absolute value of the function, but obviously this particle must be turning around at some point, correct? So what I would do is set t cubed minus 4t squared plus 7 equal to 0 and figure out where it equals 0 at. Now it's a cubic equation, and since it's a cubic equation, on y equals clear down clear. So then I'll go x cubed minus 4x squared, clear, x cubed minus, delete, slide over, minus 4x squared plus 7, graph it. I want to find the points where it's crossing the x-axis. A particle is moving along the y-axis, but I had to put it in terms of x. Gives the distance. So if we go second trace and find the zeros, this first one, we go to the left and to the right of it and press equals. Oh, for time equals greater than 0. All right. Second trace. Equals. Second trace 0. Enter. 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 So 1.772. So that must be what pi over 3 is. Yeah, did I even need to do that? No, I didn't. Okay, so we're got to integrate the position is that, total distance traveled is the integral of the velocity. Okay, so we have to find this is the position. So the velocity is 3t squared minus 8t. Okay, so if we integrate the velocity, we get the distance traveled. So 3t squared minus 8t from 0 to pi over 3, and then pi over 3 to 4 of 3t squared minus, I bet that's supposed to say 8t there, huh? Instead of just 8t. Now we got to figure out which one's positive, which one's negative. So if we take the first derivative of this, it would be yeah. So clear this out. So if we go 3t squared minus 8t graph, it's going in the negative direction at the start, the positive direction at the end. So I would say it would be negative and then positive. So I would say it's choice D, which is choice D. Okay? So the integral of the velocity gives you distance traveled. And this is a negative distance because we're going to negative velocity. Positive distance because we're going positive velocity. Okay, 33. Sorry I took so long on that one. If the integral of 0 to 4 is 10 and 8 to 0 is negative 23, what's 4 to 8? Okay, so the integral of 0 to 4 is 10. What's the integral from 0 to 8 going to be? If 8 to 0 is negative 23, 0 to 8 is 23. So then 4 to 8, you just subtract those two. So it should be 13, correct? Which is choice C. 34. If the first derivative is that and f of 0 is that, find f of x. So the first derivative is 3 sine of x plus 2 cosine of x. So we're going to integrate that. So the integral of 3 sine of x is negative 3 cosine of x, correct? And of 2 cosine of x is 2 sine of x. And then the original value is 5, so we just add on the 5 at the end. Okay, we don't have to set it equal to 0 because f of 0 is 5. So if we put in at 0, at original times 0, it's plus c, yeah, plus c equals 5. At original times 0 is 5. So negative 3, the cosine of 0 is 1, plus 2 times sine of 0 is 0, plus c equals 5. So we get negative 3 plus c equals 5, c equals 8. So yeah, it would be 8, which would be choice B, and 34 is B. 35. The graph. What is true about x equals 5? Is it differentiable at 5? No, because it goes to a point like that. So the first derivative at 5 is undefined. The value of 5 is there. The first derivative of 5 is...
It's a graph of f prime.
Oh, it's a graph of f prime?
Yep.
Oh, I didn't even read it. Graph of f prime.
That's how
So,
we get you.
yeah, that'll get it every time. Okay. So if that's the first derivative, the first derivative at 5 equals 0. And if the first derivative is 0, the slope is 0. So then if the slope is 0, it's a continuous function. So then f of 5 would be defined. So then the first derivative at 5 is first derivative 5. The answer is actually A. On number 35, the answer is A. The graph of the first derivative shown below. What is true about the function at x equals 5? And it says the curve has a cusp at x equals 5. So the curve is continuous there. Yep, I said continuous. I knew choice B would be correct. But the left-hand and right-hand derivatives are not equal at the cusp, so there is no derivative there. That means the first derivative at 5 is undefined. I don't think that's worded quite right. because that's the graph of f prime. If it would be the graph of f of x, it would be obviously a. But I think they might have made a typo on that one. All right. 36. The function is defined as that, the area between the x-axis of that and that. You just simply put it into your graphing calculator, and you got 2.682, right? So 35, they said, was A. 36, the answer was C. Easy peasy lemon squeezy, because it's a calculator question. The average value of the function between 2 and 4. So obviously you have to go 1 over 4 minus 2 of the integral of the ln of x squared, because the ln squared of x is the ln of x squared from 2 to 4. Put that into your graphing calculator. Again, it's on the calculator section. So it should be choice A, 1.204. Is that what you got? 38. The first derivative of the integral from 0 to 3x cosine of x dt is a cosine of 3x times the first derivative of that. It's the fundamental theorem of calculus. So the first derivative of that is also 3. So it's 3 cosine of 3x on 38, which is choice D. Fundamental theorem of calculus. All right. The graph of f is shown below. Good. Now it's just f. Which of the following values of x is the first derivative negative and decreasing? So the slope has to be negative. Okay, the slope has to be negative. So it's either A, B, or C. So it can't be D. Okay, and it's decreasing. So it has to be below. It's negative and going towards the x-axis. It's negative and going towards the x-axis, because if it's decreasing, it's going towards the x-axis. If it's increasing, it's going away from the x-axis. So it would be choice A. And you know how I kind of just figured that out in my brain just looking at it? B and C are basically doing the same thing, right? So it can't be both B and C, so it would have to be A. And then I thought about it a little bit more. And yeah, it is A. 40. Whoops, missed 40. Number 40. The radius of a sphere is increasing at a rate proportional to itself. Oh my. If the radius is 4 initially and the radius is 10 after 2 seconds, what will the radius be after 3 seconds? All right. So the radius of a sphere is increasing at a rate proportional to itself. The radius is 4 initially, proportional to itself. The radius of a sphere is increasing proportional to itself. It doesn't say anything about surface area or volume. So the radius is increasing at a rate proportional to the radius.
I think it's one of those CE ones, isn't it?
The radius proportional. CE to the KT? I bet it is. I bet you're right. So the dr dt equals kr. Okay? So if we say dr over r equals k dt. The radius is increasing at a rate proportional to itself. There we go. So if you integrate both sides, the integral of 1 over r dr is the ln of r, equals kt. So if we e both sides, r equals e to the kt plus c, which is ce to the kt. All right. So the radius is 4 initially. So at time equals 0, the radius is 4. So r equals 4e to the kt. Okay. And the radius is 10 after 2 seconds. So 10 equals 4e to the k times 2. So divide by 4, 2.5 equals e to the 2k. ln both sides. 2k equals the ln of 2.5. And divide by 2. K equals the ln of 2.5 over 2. We good? So we put that in back into the equation for 3 seconds. So R equals 4e to the ln of 2.5 over 2 times 3. No, after 3 seconds. Yep. So if you put that into your calculator and do all your work, you should get 15.81, choice A. All right, 41. Suppose that equals that. Find first derivative at 5. So integral 0 to x of t to the third plus t. Again, we're talking about the first derivative. So the integral of the function. So if we put in x for t. So we get x cubed plus x. And then do we just simply plug in the 5? So it's 5 cubed plus 5, which is 130, which is choice A. That's all it is. Yeah, it's just a fundamental theorem of calculus there. First derivative of the integral is just what it was. Yeah. 42. The integral of the ln of 2x dx. Okay. This is a u problem. Okay, u equals 2x, du equals 2. So we need 2 dx. So we need a 1/2 in front. So it's 1/2. The integral of the ln of 2x is the integral of the ln of u du. Ooh. Because what's the integral of natural log? No. Because the integral of 1 over... Wait. Now I'm confused. I've just totally confused myself. The integral... Because the first derivative of a natural log is 1 over x, right? So the integral of 1 over x is a natural log. Yeah. So what's the integral of a natural log? We did not learn that this year because that is integration by parts. That's now, see, that used to be in this, but integration by parts is now BC calculus. So we don't have to know this one. Do you want to know what the answer was? It was C. No, this should not be on your test. This would be on the BC Calc test. It was choice C because it's integration by parts, which, yeah, which Yeah. Yeah. So ln of whatever ax dx is x ln of ax minus x plus c. Yeah, that's what it is. But again, this is integration by parts. That in calculus in college is Calc 2 or else Calc 3. Yeah, so that's up there a ways. All right. 43. Differentiable and continuous. So ax squared plus bx plus 14 when it's less than 2, less than or equal to 3ax plus 5b when x is greater than 2. So at 2, what's going on? Okay? Because it needs to be differentiable. So it needs to be continuous. So how can these be continuous? Well, if you put 2 in for x and you set them equal each other, so a times 4 plus b times 2 plus 14 has to equal 3a times 2 plus 5b. Okay, so 4a plus 2b plus 14 equals 6a plus 5b. Now, what I would do is I would then go through the answers and just plug and chug to see which ones work. Because you could say a negative 2a minus 3b equals a negative 14. So if you don't want to deal with negatives, 2a plus 3b equals 14. So if a is negative 6 and b is 2, that will not work. If a is 6, 12, that will not work. If a is 2, that's 4, and 6 is 18. Nope. 2. Ooh. A should be 2, and B should be not negative 6. Did I make a mistake somewhere? Did I miss a sign?
The 3B. Three instead of just B times 2, it should be 3B times 2.
3A times 2 plus 5B, right?
That's
3. Oh, there's a 3 here. 6B. So then that's 1B. So it's minus. Okay, there's my mistake. Minus 2A minus B equals 14. So 2 times negative 6. Nope, that doesn't work. 2 times 6 is 12. Minus a negative 2. Ooh, choice B works.
Just
All right. Circular shock wave from the origin, 640 meters squared per second. How fast is the boundary of the shock wave moving outward when the boundary is 100 miles from the origin? Circular shock wave is spreading from the origin at a rate of 600. So it's a circle at 600. So the circle is increasing at a rate of 640 meters squared per second. So that's talking about the area if it's meters squared. How fast is the radius increasing when it's 100? How fast is the radius increasing when it's 100 miles from the origin? Okay, so the area is increasing. So dA dt equals the area formula of a circle is pi r squared. So dA dt equals, and am I going in the right direction here? dA dt, there is pi r squared. So the first derivative of this, dA dt, equals 2 pi r dr dt. Okay, so when the radius is 100, we want to find dr dt. when this is 64 and this is 2 pi. So 64 divided by 2 is 32. So 32 over 100 pi is dr dt. 32 divided by 100 pi, ooh, that doesn't look right. 640. I said 64, 640. So 320 divided by that would be choice A. Nope, choice D, 6.4. What did I not? 44 says D, 6.4. 640 meters squared, 2 pi r dr dt. All right, go to lunch and then we'll figure it out. Hey, Stan. Yep.